Yeah, so good evening, everyone. My name is Emmanuel, and if you are new here, this is Caspade, the platform where we learn about blockchain and cryptocurrency. All right, so if you are looking to grow your knowledge about blockchain and cryptocurrency, this is the right platform for you to belong to. So, yeah, we're talking about a topic. All right, so if you have been around the community, you must have seen the flyer or something. We're talking about blockchain networks. All right, blockchain networks. Sorry, not blockchain networks, blockchain layer. Forgive me, not blockchain networks, blockchain layers. Oh, who sent me? So blockchain layers. All right, talking about blockchain layers. So first of all, we're looking at blockchain, what blockchain is, then you know we drive in. So blockchain is just a kind of technology that stores information in a decentralized manner. All I'm just trying to say that the blockchain network or the blockchain itself is a kind of technology that stores information in a decentralized form. All right. So I don't know. Can you still hear me? Is
I can hear you, sir.
are you
Yeah,
still
yeah, yeah,
okay?
it's clear. Can hear you clearly.
Okay. I just hope I don't.
Yeah.
Okay. Thank God. All right. So like I said, the blockchain layers so the blockchain itself is a kind of technology that stores information decentralized in a decentralized format. What do I mean? What I mean is that when you see how the blockchain works, or when you learn the blockchain, all right, it's it performs or it functions in a very different way from other kinds of technology. That is why the blockchain technology is categorized under the Web3. All right, it's categorized under the Web3. And the outstanding thing about Web3 is that it stores information decentralized in a decentralized format. So basically, we have other kind of centralized technology. Let's use the banking system, for instance. So the banking system now, they store the information in a centralized matter. They have a database, or let's use Facebook Meta. All right, Meta is one of the biggest uh, centralized technology company we have. All right, so let's take Meta for instance. When I'm talking about Meta, I'm talking about the Facebook, Instagram, WhatsApp. I think that's just Meta. Facebook, Instagram, WhatsApp. The main company is Meta, run by Mark Zuckerberg. All right. So we notice that this thing has a centralized server, all right, where all these informations are being gathered together. That's why when you have a Facebook account, it is synced to your Instagram. All right. Sometimes you can make a post on Facebook, it's reflecting on your Instagram account. Why? All these things are centralized data. All right. So all these things are centralized technology, and you notice that at some point when the system is down, all right, when the server is down, everybody is affected. From if you've used network or Facebook or Instagram for like about a year or two, like in 2 to 3 years now, it has gone down like twice, if I'm not mistaken. I think the first time it happened, it was looking like the world was about to end. People started downloading to go. Then there was already Telegram now, so many people didn't bother much. Then WhatsApp was down, Facebook was down, Instagram was down. The whole thing was looking like the world. It was looking like the world was coming to an end. So this thing is as a result of centralized server, because if it's the informations or the technology is decentralized, even if a particular server fails, another server picks up the transaction or picks up the running of the blockchain. This is to show you that when we say that something is decentralized, it simply means that it is not powered by one server. It is not one person that is in control of it. I normally make that illustration when I'm talking about, okay, there are 5 people doing business. So these 5 people have their different record books. All right. So even if one person loses his own record books, it won't stop the business from going on, and it won't cause data loss because the other 4 have that same data. All right. So it won't cause so much of a problem. Even if 2 persons lose their own, 3 people still have their own data intact. But let's just imagine that 5 people are doing business together and there's only 1 person that has the record book. Any day something happens to that 1 person that has the record book, everything goes down. This is just the simple explanation to it. Is that okay? Hope we are following. Yeah, please, if you are
Yes, sir.
following,
Yes, sir.
yeah, even if you cannot talk, I would like you to drop an emoji in the community. All right, that would be great. Just drop an emoji in the community to to motivate me. Thank you. I like being motivated. Good. Thank you. So, because of this thing I explained about the blockchain technology, this decentralized format, there is an architecture that makes this thing functionable. There is an architecture that makes this thing work. Okay, still something about the blockchain before I go into the blockchain layers itself. When you talk about the blockchain have different types of blockchain. We have the public blockchain, the private blockchain, the hybrid, and the consortium. All right, I think someone should, even if you followed us for about, let me say, about a month or 2, you must have heard me mention this thing. Like, I think almost every class I hold, I talk about blockchain. I try to go over these basics. So 4 different types of blockchain: the public blockchain, private blockchain, the hybrid, and the consortium. So you can just write it down and research it on your own, because I'll not be discussing them because that's not like really our focus. I'm just giving an introduction to lay a foundation. So the security of this blockchain layer is being linked to the blockchain architecture. So the whole thing about the whole blockchain thing is, it's secured, you can't tamper with it. And, the whole features of the blockchain, it is secured, it is transparent, it is this, it is that. All right. It's being hinged to the architecture of the blockchain. It's just like when you are building a house and you say, okay, this house is strong, you can't penetrate. If you've heard about building, the way they build a bank, all right, in a bank, there's what they call safe room, where the main money is kept. The way they build that safe room is not the way they build every other part of the bank. All right. So I've been privileged to see where they are building a bank. And like, even from when they were building, I already knew that there was something special, because the safe room, where they were using block to do other parts, the safe room they used what they call it. They were using rod, right? They were using iron to work on that part. So it should be clear to you that, oh, there is something. Give me a sec, guys. All right. So, like I said, is someone saying something? Okay, we are still together. So, like I said, when they are building a bank, or if you've seen where they are building a bank, there is what you call the safe room, and this safe room is quite different from other parts of the bank. This is where money is being stored. So, what I'm trying to illustrate is that from the way the blockchain architecture is built, you could easily tell the features it will have. So this architecture of the blockchain is presented in layers, but there are 2 different kinds of categorizing of these blockchain layers. So one is being categorized under its architectural function, all right, while another one is being categorized under a different level of infrastructure and protocol development. One is being categorized under this thing, architectural function, all right, while the other blockchain layer categorization is according to its development protocol or protocol development. Are we together? I'll be explaining these things. So I think it's time to start dropping images. Okay, so I'll be discussing the first one I mentioned, the categorizing, the blockchain layer categorization according to function and the architecture, according to the blockchain architectural functions. So I'll be dropping an image here which will be guiding us. So if you check the chart now, you'll be seeing an image. So if you check the chart, you'll be seeing an image. Let me share screen so that you can see my screen here. So I just want to have this chart on my screen. Everyone can see my screen. Everyone can see the image on the screen here.
Yes, sir.
Okay, perfect. Okay,
Yeah,
perfect.
I can see it.
All right, great. So we'll be discussing about these different blockchain layers, and this layer categorization, like I said earlier, is under architectural function. All right. So this is the first part we'll be discussing. That's why I had to start quite on time, because we have a long way to go. All right. So we'll be talking about the data layer, which is that is the base layer. All right. From here, even though they put it, why it's down is because it's the base layer. So we'll go from down to up. All right. So talking about the data layer. So when talking about the data layer here, the data layer stores the actual data in the blockchain, including transactions and cryptographic elements. All right. So this data layer is simply responsible for storing transactions. All right. It's responsible for transaction storage. So when you carry out a transaction in the blockchain, maybe you perform a transaction, you want to send Bitcoin to someone, you want to send Ethereum to someone, you want to send Solana to someone, you want to send USDT to someone, the part of the blockchain that is in charge of this thing, that stores this particular information. If you remember, there was a day I was teaching a class and I sent you my Ethereum address. My BSC address, Ethereum address. It depends on which this thing you're using, Explorer you're using to check it. So I sent my BSC address and I told you guys check BSC scan. You were able to see different transactions I carried out since I created the wallet. All right. So it is the data layer that the data layer part of this blockchain, which is like the base layer, that takes care of this part of the blockchain, or this kind of functionality of the blockchain. Are we together? Are we
Yes,
together?
sir. Yes, sir.
Yes, sir.
Okay, fine, great. So we'll be talking about, so from here, the image, you can see, okay, it gives some rendering. So the data block, chain structure, and timestamp, they fall under the data layer. So from here, you have the blocks, all right? So the key components of the data layer is the blocks. That is block. When in the blockchain technology, transactions are stored in blocks. That is the whole idea about blockchain. So the word blockchain is come from blocks and chain. So it is simply saying that these transactions are in blocks and they are connected in chains. That there is no other. This is just where the whole blockchain thing came about. I think even if you see the flyer of the class, you see there was an illustration there where blocks were held with chains. Chains were linking different blocks together. I think if you just can check the flyer of this class. So this is just trying to explain how the blockchain structure looks like. All right. So the blocks, this is the basic unit storing data. So for example, in Bitcoin, excuse me. So in Bitcoin, transactions are stored in blocks, something like I said earlier. So like the key components of this data layer is the blocks, the transactions, that is the record of these data, right? The transaction record whereby, okay, I sent A sent 2.50 BTC to B. This is the transaction record, like I said. So all these things are being taken care of by the data layer, or this information will be stored by the data layer. Then I mentioned the blocks, I've mentioned transaction, then cryptographic hashes. So this is the part of the data layer that makes sure that these transactions are secured. All right, it makes sure that these transactions are encrypted, that you can't be able to tamper with it. So no one has the right to tamper with a transaction. And this whole thing is possible because of this cryptographic hash. So it's basically, this cryptographic hash is basically used to secure data. All right. So that when this cryptographic hash, or if you've heard of like transaction hash is maybe someone sends you money. I think maybe if you have tried sending money before, maybe from your Trust Wallet to send someone USDT or BSC. When you perform the transaction, a transaction hash is created. That transaction hash is like a link. All right. That link is to tell you that, oh, so money moved from this wallet to this wallet. That information is there. Nothing anybody can do to manipulate it. It's already registered, it's already recorded in the blockchain. And this cryptographic hash gives you that functionality that nobody can go there and rewrite what is already. You cannot send 0.2 BTC, then you go to the transaction and write 0.5 BTC. It's not possible. So this is why the blockchain technology is superior. All right. So we just talked about the data layer. Then now we're talking about the network layer. This is the network layer. So this is the layer that manages communication between the nodes, networks, facilitating the sharing and synchronization of data. So this particular layer now is what manages the interaction between two nodes. What are nodes? Nodes are PCs or computers that power the blockchain. So, you know, when I told you that the blockchain is decentralized, and this is simply mean there are different sources powering this blockchain, and these different computers are called nodes. So the interaction, you know, when the transaction is going on, when the transaction is sent into the blockchain, there are different nodes that can, you know, handle the transaction, or let's say approve the transaction. I think if you can refer to when I did admin go, I think when I did a teaching on Bitcoin, I taught on how Bitcoin transaction works in that particular class. I think it should be on our YouTube. So if you go through, I'm referring to that teaching, go back, listen to it, watch that particular video. I made a physical illustration of how Bitcoin works. I explained that thing, so that thing I explained there will help you understand the interaction between nodes. All right, because when a transaction is sent, maybe person A wants to send Bitcoin. I'm using Bitcoin for example. It could be any cryptocurrency. You send Bitcoin to person B. So it's just like I've made a request. So there are different processes that happen before the cryptocurrency gets to person B. All right. So there are a lot of things that go on in the blockchain, and you know, part of what goes on in that blockchain is some of them are happen in the data layer. You know, when the transaction gets into a block, then when the transaction gets to a block, it's been approved, then added to the blockchain and everything. So I think I actually want you guys to, you know, watch that class. So this network layer, like from the image you're seeing on the screen, so it handles communication. All right, it handles communication between these nodes. Like I already told you what nodes are. So these nodes are what approve and validate transaction. So in the Bitcoin blockchain, it's called approving transaction, which the people, or you call them mine, this whole process of approving transaction is called what you call mining. And yeah, it's what you call mining, because when these transactions are approved by these particular nodes, and the people that approve this node for the Bitcoin blockchain, they are called miners. For the Bitcoin blockchain, which uses the proof of work consensus mechanism, these people are called miners. For the Ethereum blockchain, which uses the proof of stake mechanism, these people, or these computers, they are called people behind these computers are called validators. All right. So I think we also have a teaching on consensus mechanism. I refer to it so that I won't be explaining this thing so much. So please, admin, as I'm saying this thing, any class, any teaching I refer to, please drop the YouTube link so that people can lay hold of it and watch. All right. So another key component of this layer network is P2P protocol. So P2P protocol is for data distribution. So for example, Bitcoin uses the Gossip protocol to propagate transaction and block across the network. So it still has to do with the whole transaction thing. So this is where the network layer. So it's just this whole network layer is just taking care of communication between nodes, all right, and these systems that power the blockchain technology or a particular blockchain network. Is that okay? So it still focuses on how these nodes interact and how a transaction is being approved by these nodes. All right. So this whole process fall under what you call consensus mechanism. So we now have the consensus layer. All right. So this consensus layer ensures that all participants in the network agree on the data state and the sequence of transaction. This is like when they are talking about participants now, I'm talking about people that are nodes. So consensus simply means agreement. When you have consensus. So this is just like this layer of the blockchain is what makes all nodes agree to the approval of a particular transaction. All right. So when the transaction is carried out, nodes must be able to be like, okay, we are in support of this transaction. All right. We are in support of this transaction. So this is simply how the consensus layer works. So some of the key components is consensus algorithms, the proof of work, the proof of stakes, mining and validating nodes. Something like I mentioned earlier. I mentioned some of this earlier in the network layer. All right. And just to bust your bubbles, these things, they are, even though they are trying to be separated, we are trying to separate them in layers and everything, but these guys work hand in hand. That is why things that I'll mention in a different layer, they will come in another layer, and things I mentioned in this one will come in another one, because this is a whole technology. They are intertwined. All right, they are intertwined, they are interjoined. Even though, yeah, they have different layers of functionality, but they are serving each other at different capacities. All right, so because from when we're talking about the whole data layer, even the whole transaction thing, these transactions are being approved by are being approved by the network layer, which are carried out by the consensus layer. So these things are quite interconnected. All right. So we are talking about the consensus layer. So like I mentioned, the components is the consensus algorithm, which is which we have about things like, okay, the proof of work. So this proof of work is the consensus mechanism for Bitcoin. Bitcoin uses the proof of work consensus mechanism. So it's used by Bitcoin. So this is just like basically how when miners compete to solve a cryptographic puzzle to add blocks. So this is just the whole process of a transaction being carried out. So for a transaction to be approved, for a transaction to be approved, so it's just like different nodes are competing for who will verify this transaction. So whichever node solves the complex algorithm first takes credit for approving the transaction and gets rewarded. Is that okay? Are we still following? Are we still following? Sorry, I know these
Yes,
things
sir.
can
Yes,
be
sir.
okay, great. I know these things can be quite confusing, but don't worry, with time you will understand it and get used to it. So yeah. So please, if you're still following, I would like you to drop like a sticker, an emoji in the community, all right? So that it motivates me. I really appreciate your motivation. So I already talked about, so from here, the consensus layer, where we are dealing with the consensus mechanisms. So where we are talking about, okay, like I mentioned, the proof of work, then the proof of stake is used by Ethereum, where validators are choosing to create new blocks based on their stake. So this stake now is based on the amount of cryptocurrency they are holding. So this is how proof of stake works, where people are being selected or transactions are being approved by validators depending on the amount of stake they have. So the higher stake you have, that the higher the amount of, we are using like talking about Ethereum now. So the Ethereum uses the proof of stake. So the higher the amount, the bigger the amount of Ethereum you staked or you have. It depends on the level of transactions you can validate. So you stand more opportunity to approve more transactions when you have a higher stake. All right. So the whole things so you have so still under this concept, you have the mining and validator nodes. So nodes were mentioned earlier in the network blockchain. So it's still the same process of, where nodes carry out different activities like approving a transaction. Okay, so if you look at the image there, you're seeing proof of work, you're seeing DAG, you're seeing proof of stake, different proof of a lot of things here. So you can just check it out, all right? So you have POS, POE, POX, BFT. And if you're paying attention, these consensus layers, we mentioned, I think, the proof of liquidity and the rest of them. We mentioned most of them in the class we had last week. This is simply why, I think if you followed our class last week, we mentioned, you must have heard DAG. I mentioned DAG. And we mentioned that this is a BFT. All right. So this is why I urge you, don't miss our classes. All right. Because some of the things we'll be saying will be interconnected. So these consensus layers, all right. So to understand it better, watch our videos on consensus mechanism. Apart from watching our videos on consensus mechanism, you can watch blockchain networks. All right. Some of these things I mentioned. So I'm referring to our last video so that you can have a better understanding of some of these things. So another layer we're talking about is the incentive layer. The incentive layer. So the incentive layer, this is the layer that provides economic incentives for participants to secure the network and validate transaction honestly. So this is a part of, when we were talking about the whole transaction approval, and I said that process where a transaction is being approved and the node that approves the transaction is being rewarded, or the miner that approves the transaction is being rewarded. This is the incentives layer. This is the part that take care of the rewarding, or what we call mining. Is that good? So when this layer now is what makes people to be honest, okay, to validate transaction honestly, because they are gaining. So when people are gaining from something, they tend to be honest. All right. Just imagine somebody's paying you for telling the truth. Why won't you tell the truth when you are getting paid? All right. So this reward is what makes people to get honest with, approving these transactions. Is that good? So it makes them put them in check that, okay, this transaction are approved in order, and because they are, at the end of the day, they are getting rewarded. They are getting rewarded for it. So the key components are, you hear about the token. So they benefit from token and transaction fees. So this layer now, the key components of this layer is the token, and transaction fees. Okay, token now is both tokens and cryptocurrencies. So I've already explained what difference between tokens and cryptocurrencies, or tokens and coin. Okay, all of them are cryptocurrencies between tokens and the coins. So token is cryptocurrencies that don't have their own blockchain, while coins are cryptocurrencies that have their own blockchain network. Is that good? So sorry. Yeah. So I mentioned the key components of this incentive layer. So these digital assets are used to incentivize participants. All right. So like I mentioned earlier, the miners reward and the transaction fees paid by users to prioritize the transaction. So this layer 2 takes care of the what you call transaction fee. All right. So when you are trying to run a transaction on a blockchain, they will tell you, okay, gas fee. So this gas fee or transaction fee, they are talking about the same thing. So it's still this the transaction fees. Okay, maybe you are using a DApp, you are trying to stake, you are trying to perform a transaction or an activity on the blockchain, and they are charging you gas fee. This thing falls under this layer. It's from these gas fees that these miners are being rewarded, because they are charging little money, depending on the blockchain though. Because blockchains like Bitcoin and Ethereum, their gas is not here. So, but looking at projects like BSC, Solana, they charge very little, right? Charge something very, very little. So, yeah. So this incentive layer takes care of this thing. So we'll be looking at the next one, the contract layer. The contract layer. Okay. So this contract layer is the layer that enables the execution of smart contracts and programmable transactions in the blockchain. So this particular layer now is what takes care of this whole smart contract thing. You've heard of, I think we also have a teaching on smart contracts. We have a record, I think we have a recorded teaching on smart contracts, right? So you can also refer to it. I think even if it's not on YouTube, I think we have the recordings. So we have some of the recordings. I think admins, please provide this information for the community so that they can go through some of these things, so that they will understand fully what we are talking about. So talking about smart contracts, so the key components of this contract layer, I mentioned smart contracts already, then virtual machines. All right. So these smart contracts are self-executing contracts with terms and conditions, okay, written with a written agreement in the code. So this contract now is why they are smart is because it is self-executing. So let's just say we have an agreement between me and maybe one of us. Who is on the call? So let me just say we have an agreement between me and Danny, all right? So me and Danny will have an agreement. So, excuse me. The agreement between me and Danny, all right? So this thing, so Danny is supposed to do a work for me. So when I write it in form of a smart contract, so once Danny delivers this work, and I'll be like, okay, this work, it must have this, it must have that, it must have this. So once Danny does that work and it meets these requirements, payment automatically goes out to him. So let us say, okay, create a smart contract where I put in money. So I'm going to pay $100 for this work, and the $100 is in the smart contract. All right. So my wallet signs, his wallet signs. So that is, I sign, he signs. So this signing is by your wallet. You use your wallet to sign smart contracts. So that's why if you open some dark pages, they tell you sign in, or when you visit them, they tell you sign in. So approve, sign. All these things is you signing. You are giving them permission to use your wallet. So I have $100 in my wallet. Danny has money. It's, that needs to do work for me. So once Danny does the work and it meets the requirement, without my permission, my $100 is moving to him. So I don't need to send the money again. So once the blockchain sees that, okay, these parameters are met, these requirements are met, the money goes out to Dan immediately to his wallet. This is simply how smart contracts works. So it's smart because it's a self-executing. So even if I didn't have in mind to pay Danny before, it's not going to work. Why? Why is it not going to work? Because the money is being carried out by itself. So before I sign,
now
can someone meet that person, please? Thank you. So you see the thing now. So for me to even sign means that, okay, there is $100 in my wallet. The smart contract says, oh, I have this $100 to pay, and Danny decides because, okay, once I deliver this work, the $100 is mine. So it's this smart contract. I'm just using a real life illustration to explain the whole smart contracting. So does it breach trust? It creates trust. Right? It creates an element of trust between two people because nobody gets to be cheated in such deal. Right? So that is just a little explanation of smart contracts. So another component that falls under this contract layer is virtual machines. So virtual machines is what executes smart contracts. So virtual machines are the ones is the powerhouse that executes smart contracts. All right. So like now, you must have heard of Ethereum virtual machines, EVM. You hear that, oh, this is EVM compatible, EVM this, EVM that. EVM means Ethereum virtual machine. So for the Ethereum virtual machine, the Ethereum virtual machine is the virtual machine is responsible for executing the smart contracts on the Ethereum network. All right. So when the smart contracts that are being smart contracts are being created on the Ethereum network, the EVM is responsible for the execution. All right. So this is for the contract layer. So for this particular so how many layers have we mentioned so far? We've mentioned the data layer, we've mentioned the network layer, we've mentioned the consensus layer, we mentioned the incentive layer, we've mentioned the contract layer. I really hope we are taking notes. Then we're talking about them the application layer. All right. So this application layer here, the application layer consists of user interface and APIs that allow interaction with the blockchain. So this application layer is the part that we see. All right. We say, oh, you call it decentralized applications. All of them fall under this application layer. So yeah, calling it these different decentralized applications, they fall under this application layer. This is the layer that carries these different infrastructures that are being built on the blockchain. This is where dApps are built, different things are built, This is like where we create a bridge between the user and the blockchain, where you can be able to swap tokens, you can stake tokens. What are different kinds of decentralized application? You can what's one of these different apps? My NFT marketplace. This is this that, and the rest of them. All right. So yeah. So that's the thing. Is that okay? So these things I mentioned now are being taken care of by the application layer. Okay. So key components, the dApps, the decentralized application, like I mentioned earlier. So they have the user interface. This is user interface is like what you call front end. All right. So this front end is the UI. This is like when you visit a decentralized application, the part that you see is what you call the UI. Okay, let's say you're trying to swap a token. The place you're carrying some of these activities, what you're seeing there is UI. You don't really know what's happening behind the scene. Your own is that you click on the stake button and your token gets staked, or you click on withdraw, you withdraw your token, different activities. So the application layer takes care of the interaction between this UI and the blockchain. Okay, so and the connect wallet function, where you click on connect wallet, most of us who have used a different application, you understand what I'm saying. So when you click on connect wallet, it triggers the wallet. It could be your MetaMask, it could be your Trust wallet, where you sign in, they tell you sign in, they tell you approve. All those things are taken care of in the application layer. They tell you swap and have different components. So you have the APIs too. So this is some developer features where developers can access some how will I put it, some plugins, all right, application plugins, where they can use to build their own product. So all these whole things fall under the application layer. So this what do you call it? This is to show you that these different layers of blockchain are interconnected with each other. All right. So each layer of the blockchain supports each other. So basically, the data layer ensures all transactions. So I'll just give you a rundown summary of everything I've been speaking today. So basically, for the data layer ensures that transactions, all right, transactional data are securely recorded and linked. All right. Then the network layer disseminates this data across all participating nodes. Okay. So this is what the network layer does. The whole English I've been speaking. The consensus layer ensures that all nodes agree on the data validity and sequence. I hope you are getting what I'm saying. So this is to show you like the connection between, like, this is just to show you when a transaction happens, this is what's happening behind the scene. So the incentive layer, is someone saying something? Okay. So this incentive layer motivates participants to contribute to the network security and integrity. Then the contract layer enables complex transaction and application, adding functionality beyond simple transfers. So this contract layer is what when Bitcoin was created, Bitcoin was just basically transactional transfer, just simple transfer of buying and selling. Sorry, not buying and selling, sending and receiving. So Bitcoin was just about, you send Bitcoin, you receive Bitcoin. It was just that. It had a wallet where you could send and receive. That was just everything about, the Bitcoin. So, but this contract layer that was introduced to the blockchain, or this contract layer part of the blockchain, is what makes the blockchain more fun. That is why you now have gaming, you now have a staking, you now have a yield farming, different activities on the blockchain. These things are taken care of in this contract layer. Then the application layer now provides the tool and interface for users and developers to interact with the blockchain. So where we interact with the blockchain, when you say you're interacting with the blockchain, it's not like maybe you're inside the blockchain playing. It simply means that you are interacting with the blockchain from an interface, and this interface now is when I mentioned, like, okay, like now I mentioned things like staking. When you're trying to stake a token on, maybe what's the popular staking platform, now? Maybe Aave or lending or borrowing, all these different applications that run on the blockchain. So when you're interacting with these platforms, this decentralized application, it simply says they are interacting with the blockchain. So it's this application layer that creates the bridge between the real world and the blockchain technology. So this is everything about the structural functionality. All right, the blockchain layer categorization under structural functionality. So like I said, we have a layer categorization under protocol development, infrastructure and protocol development. So, but I want to get our questions, all right, because if I go into that, we will not be able to finish it today. So next week we'll start from there. Then that is where we'll be talking about layer 0, the ones some of you might be conversant with. You've heard of layer 0, layer 1, layer 2, blockchains, they hear, scaling and the rest of them. So that'll be that. So I would like to take our questions. So I would like to take our questions concerning what we discussed. Does anyone have any question? Someone can hear me clearly. Please. Chiemeka. I don't know. No admin called my attention to that. Are you serious? I think it should be from your network. Is there another person having this issue? Okay, I think it should be from your network. Okay. Okay. Okay, I was saying something about okay, that's the application layer. All right. So the application layer, this is the part of the blockchain that takes care of the human interaction with the blockchain technology. So it's just that interface where we are able to interact with the blockchain. So that blockchain layer is that interface, where you can say, oh, connect wallet, swap token, stake token, the staking, the swap, the yield farming, the lending and borrowing, different decentralized application. So this is the part of the blockchain that takes care of this activity. So I don't know if you get that now. So that is I'm talking about the application layer. It's the application layer that has that feature. So the key components. So I think I'll just drop this summary for us so that this is just like a summary of the whole English I've spoken tonight, so that so this is just the summary of the whole English I've spoken tonight. I'm dropping it in the group now. So this is like the summary of everything I've mentioned, and the image I sent to it will help you and give you a guide. So with that summary, you should understand what we are talking about. So any other questions? Any other questions? Any question concerning what we've discussed so far? Okay. All right, you're welcome. Okay, guys. All right, cool. So this is like the categorization of blockchain layers according to the architectural function. All right. So, and I said that next week we'll be talking about, the layer categorization according to its protocol development. That's why you'll be hearing about layer 0 blockchains, layer 1 blockchains, layer 2 blockchains, and the layer 3 blockchains too, even though that one is quite new. So, and the thing is that they are quite connected to these ones, but we'll be discussing them in a little bit different light and different angle. So we'll be discussing the layer categorization in a different kind of functionality. Okay, so that's it. So thank you everyone for joining. So if you're new here, sorry, let me stop.